If I showed you Google Street View in the 1990s, you'd think it was science fiction. Type any address in the world and instantly see what it looks like at street level, walk around virtually, and even go back in time to see how it looked years ago. But it exists now, and it's free. And you might think that it's all possible due to those Google Street cars you see driving around. And you'd be right, barely. Google Street View cars are more complicated than you think. They're less cars and more a data center on wheels. The latest generation carries 15 cameras shooting 140 megapixels each, capturing 360-degree views every 2.5 meters. That's 400,000 high-resolution images per car per day, more photos than the entire Library of Congress collected in its first 100 years. But cameras are just the beginning. Each car is equipped with LiDAR sensors firing 700,000 laser points per second to create precise 3D maps, while GPS arrays track its position with accuracy down to 10 centimeters. That's like knowing exactly which ceiling tile you're standing under in any building. The onboard computer vision systems process a staggering 1.2 terabytes of raw data every hour. And to keep all this sensitive equipment steady, each car uses custom stabilization rigs that cost more than the vehicle itself. The evolution of these systems tells a story of relentless improvement. The first Street View cars in 2007 used basic DSLR cameras mounted on a pole. Today's units use custom-built sensors that can capture details in shadow while handling bright sunlight in the same frame, something even the human eye struggles with. Most impressively, these systems work at highway speeds. Each car processes more visual data in 1 hour than humans can in a month, all while maintaining image quality that lets you read street signs from 50 meters away. For perspective, a single day of Street View capture generates more data than all photos taken worldwide in 1990. All these images are then thrown into the quality check system called Google Vision, which uses HDR, or High Dynamic Range, fusion, combining multiple exposures in real time to handle extreme lighting conditions. Each captured frame undergoes instant geometric correction for lens distortion and perspective adjustment. Speaking of, thanks so much for all the support on the channel lately. It really means a lot, and I want to give something back to you guys. So do you need a job? That sounded a bit weird. But whether you're a UX designer, app developer, freelancer, or just a curious viewer, I want to get to know you guys, share some UX and UI tips, and maybe even get a gig. So I made a Discord channel for us and want to make this the place to be for front-end professionals. And I'm having talks with people to get some employers in there so you can connect with them too and find some jobs in the future. I'm really excited to get this thing started, so I hope you'll join me. The system's neural networks provide a real-time quality assessment, analyzing factors like motion blur, color accuracy, and exposure consistency. If an image doesn't meet quality thresholds, the system automatically flags that location for recapture. The vision pipeline includes sophisticated depth estimation algorithms that create detailed depth maps from stereo image pairs, enabling accurate 3D reconstruction. Most impressively, the system employs advanced image stabilization that combines both optical and electronic methods. Gyroscopic sensors detect minute vibrations 1,000 times per second, while machine learning algorithms predict and compensate for vehicle movement before it affects image quality. This enables sharp captures even on rough roads or at highway speeds. But having millions of perfectly captured images is like having all the pieces of the world's largest puzzle. They still need to be put together. And this is where Google's real technological achievement comes into play, turning all these disconnected snapshots into the seamless virtual world we can walk through with a click. To understand the scale of this challenge, consider the numbers. Each Street View car generates 400,000 images per day. Multiply that by hundreds of cars operating worldwide, and you're looking at processing millions of images daily. So how does Google manage all this? The first step is photogrammetry, the science of making measurements from photographs. Custom algorithms analyze every image, identifying up to 50,000 distinct points per photo that match across multiple frames. This creates what engineers call a point cloud. Imagine pushing pins into every recognizable feature in a photo, then connecting them across hundreds of overlapping images. The system processes 1.5 billion such points every minute. But matching points is just the beginning. Machine learning algorithms then perform what's called semantic segmentation, identifying and categorizing every object in view. This helps the system understand what it's looking at: buildings, roads, trees, signs, and even temporary objects like cars or pedestrians. The system can differentiate between permanent features that should be preserved and temporary ones that might need to be removed or averaged out across multiple passes. The final step is the actual stitching, where these analyzed images are blended into seamless panoramas. The system processes over 100,000 panoramic stitches per hour, each requiring calculations that would take a high-end laptop several days to complete. The result? A virtual world where you can't see the seams between photos, unless you know exactly where to look. But creating these perfect panoramas introduces another massive challenge. Where do you store the largest photo collection in human history? To put it in perspective, a single day of Street View captures more visual data than all the frames in every movie ever made before 1992 combined. But size isn't even the biggest challenge. This data needs to be instantly accessible to billions of users worldwide, while also preserving historical imagery going back 15 years. Google's solution combines three ingenious systems. First, their custom compression algorithms shrink each panorama by 95% without visible quality loss. Imagine squeezing a phone book into a pocket without losing any numbers. Second, they use predictive loading that anticipates where you'll look next, preloading those images before you even click. It's like having a librarian who knows which book you'll want next before you do. The most impressive part is the storage architecture itself. Instead of storing complete panoramas, Google breaks each view into thousands of tiny fragments, distributed across their global network of data centers. When you look at a street, you're actually seeing pieces assembled from dozens of servers worldwide, all coming together in less than 100 milliseconds, faster than it takes to blink. This is all thanks to Google's delivery system, which is more like having millions of miniature movie theaters playing simultaneously, each customized for every viewer. The system uses what engineers call progressive loading, starting with a low-resolution version that loads in milliseconds, then gradually sharpening to crystal clarity. Think of it like a painter quickly sketching an outline before filling in the details, but happening in fractions of a second. The real genius is in the prediction algorithms. As you move down a street, the system is already loading the next several views in every possible direction. It analyzes your movement patterns, connection speed, and even the time of day to predict which images you're most likely to request next. On average, the system predicts correct user movements 87% of the time, meaning most images are ready before you even ask for them. To make this possible, Google maintains a network of edge servers in over 200 countries. When you request a Street View location, you're actually connecting to the server physically closest to you, not some distant data center. These edge servers cache, or temporarily store, the most frequently viewed locations in their area. It's like having a local library that keeps copies of the most popular books, but automatically updates them every few minutes. And at the heart of this system is something for the people that don't want to be photographed: what engineers call differential privacy, automated AI that can detect and blur faces and license plates in real time. The system processes 8.2 million privacy-sensitive objects per hour with 99.9% accuracy. The technology goes far beyond simple face detection. Google's AI can recognize military bases, domestic violence shelters, and other sensitive locations that require additional privacy measures. In some countries, entire categories of buildings must be automatically obscured. The system handles these regional variations automatically, applying different privacy rules based on local laws and cultural norms. But perhaps most impressive is the right to be forgotten system. When someone requests their property be removed from Street View, Google's algorithms can automatically find and blur every instance of that location across their entire historical archive. In 2023 alone, they processed over 500,000 removal requests, each requiring analysis of hundreds of connected images. Think of it like trying to remove someone from every photo ever taken at a party, but the party is the size of a city. All these systems, the cars, cameras, processors, storage, delivery, and privacy protections, work together in perfect synchronization to create something that would have seemed impossible just 20 years ago: the ability to virtually walk down almost any street in the world. But Google's ultimate goal isn't just to show us the world, it's to help us understand it. And how Google Street View works is entirely different from the app it's embedded in.